Morning everyone, myself K. Prashanak from Civil Department second year. Topic: shear stress distribution for I section. Shear stress distribution for I section. Introduction to shear stress in I section. Shear stress distribution in I section in circular for understanding their structural performance. Is variance across different parts of the section, implication of the design and safety, the participation exploration, the shear stress distribution, specifically I spaced beam, geometric for I section. In I section consist of two planks connected by a web forming an I shape. The web is the vertical in the primarily resist shear force will the flanks resist bending. Understanding the geometric help in analysis of shear stress distribution within the section. Shear stress, shear force and shear stress fundamentals. Shear force is the internal force acting parallel to the cross section area. Shear stress in a distribution for of shear force divided by the area resting it. I beams shear stress variance across the cross section, typically packing near the web flank junction. Shear stress in the web. The web of the I section carries most of the shear force due to its vertical organization. Shear stress in the web is generally uniform across in its height, assumption a constant shear force. The web's shear capacity is circular to prevent web bulking and failure. Shear stress in the flanks. The flanks mainly resist bending moment but also experience shear stress explanation near the web flank junction. Shear stress in the flanks of the typically lower than the web and variance across the flank within. Purpose consideration of the flank shear stress is necessary for compression design. Calculation shear stress in I section. The shear stress can be calculated using the shear formula T is equal to V cube by IT, where V is shear force, Q is the first moment of the area, I is the moment of the inertia, and T is the thickness, shear flow. Q is equal to V Q by I. Providence is detailed views of the shear distribution along the section. This calculation are essentially for achievement stress analysis is the shape design. Shear stress distribution across the cross section. Shear stress distribution in a I section in a non-uniform packing near the web flank junction. The shear flow is the highest at the web flank. Interference is a declination towards the flank edges. Understanding this distribution helps in the designing refoundment and ensuring structural factors after shear stress distribution. Web thickness is the flank within inclination whose shear stress is the distributed within the I section. The overall size and space of the section affect the magnitude and distribution for shear stress. Material properties and loading condition also by significant role is the shear behavior. Practically, consistent is design. Remained forcing the web or the adding. Stiffness can improve shear capacity where stress pack, ensuring purpose web to flank junction design helps provided shear failure. Regular inspection and the maintenance are vital to discretion shear related issue yearly. Conclusion to summary. Shear stress distribution in I section is complex but vital for the safe structural design. The web carries most the shear force with shear packing at a web flank junction. Proper analysis and the remain reformment ensure the durability and the safety of I section beams. Thank you.